In this module, we will be introduced to the concept of three-dimensional geometry. Coordinate geometry helps us in describing the location of points in space. Look at the real number line shown. This line provides us a means by which we can show the location of real numbers, be it rational or irrational. Assume that this line represents the length of the rectangular floor of a cuboidal room, such that the origin of the number line coincides with one of the vertex of the rectangle. Consider that a ball is rolled along the length of the floor. The number line helps us pinpoint the position of the ball at different instants of time. For instance, we can see that the ball has stopped at the location represented by the point 5. A real number line can be thus considered as a one-dimensional coordinate system. Now, consider that the ball is moved such that it reaches some point on the floor of the room. The one-dimensional coordinate system is not sufficient to pinpoint the location of the ball. Hence, we draw another number line perpendicular to the horizontal line. This gives us the two-dimensional coordinate system, which helps us locate a point lying on a plane. The horizontal and the vertical axes, known as x and y axes respectively, give us the horizontal and vertical distance of the point. By convention, we represent a point on the xy plane using an ordered pair x, y. Thus, the coordinates of the ball can be given by the ordered pair 6, 4. Note that the x-coordinate gives the distance from y-axis and the y-coordinate gives the distance from x-axis. The two axes divide the xy plane into 4 quadrants, Q1, Q2, Q3 and Q4. The sign for each coordinate of an ordered pair depends on the quadrant in which the point lies. Now consider that the ball is tossed vertically upwards and it reaches a point P at some instant. How do we locate this point? The position of point P cannot be uniquely described by the two-dimensional coordinate system. As the ball moves upwards, it moves away from the xy plane. Hence, in order to pinpoint the position of the ball, we need to measure the distance of the point from the xy plane. In order to measure this distance, we draw a third number line known as z-axis perpendicular to both x and y axes as shown. This gives rise to a three-dimensional coordinate system. We can see that the point is at a distance of 5 units from the xy plane. So, in order to reach this point, we need to move 6 units along the positive x-axis, 4 units along the positive y-axis, and then 5 units along the positive z-axis. The location of the point can be given by the ordered triplet x, y, z. For the given point, the x, y and z coordinates are 6, 4 and 5 respectively. To get a better understanding of this three-dimensional plot, let us construct a box as shown. From the plot, we can see that the x-coordinate gives the distance of the point from the yz plane. The y-coordinate gives the distance of the point from the zx plane. And the z-coordinate gives the distance of the point from the xy plane. Now, consider that we need to plot a point with coordinates as shown. For this, we move 3 units along the positive x-axis, 5 units along the positive y-axis, and finally 6 units along the positive z-axis. Now, consider the cuboid shown. 6 points have been identified. Identify the coordinates of each of these points. 6 options have been provided. Click any option and then click the empty slots. Click the Submit button after selecting the coordinates of all points. The X, Y and Z axes divide the space into 8 octants as shown. Click any octant to learn more about it. The octant 1 is determined by the positive x-axis, positive y-axis and positive z-axis. As a consequence, for any point in this octant, all the 3 coordinates are positive. Octant 2 is determined by the negative x-axis, positive y-axis and positive z-axis. As a consequence, any point in this octant has a negative x-coordinate, whereas the y and z coordinates are positive. Octant 3 is determined by the negative x-axis, negative y-axis and positive z-axis. As a consequence, any point in this octant has a negative x-coordinate, a negative y-coordinate and a positive z-coordinate. The octant 4 is determined by the positive x-axis, negative y-axis and positive z-axis. As a consequence, any point in this octant has a positive x-coordinate, a negative y-coordinate and a positive z-coordinate. Octant 5 is determined by the positive x-axis, positive y-axis and negative z-axis. As a consequence, any point in this octant has a positive x-coordinate, a positive y-coordinate and a negative z-coordinate. The octant 6 is determined by the negative x-axis, positive y-axis and negative z-axis. As a consequence, any point in this octant has a negative x-coordinate, a positive y-coordinate and a negative z-coordinate. The octant 7 is determined by the negative x-axis, negative y-axis and negative z-axis. As a consequence, for any point in this octant, all the 3 coordinates are negative. Octant 8 is determined by the positive x-axis, negative y-axis and negative z-axis. As a consequence, any point in this octant has a positive x-coordinate, a negative y-coordinate and a negative z-coordinate. Let us now summarize what we have learnt in this module. We have seen that a 3-dimensional coordinate system is required to locate a point in space. Further, we have seen that such a system is described by x, y and z axes. We have also seen that these axes divide the space into 8 octants.